Hello and good morning friends, welcome to CEC-UGC live lecture. Dear friends, we are delighted to tell you that we are successfully conducting a series of lectures on operation research, and so far we have conducted numerous lectures, and these lectures are beneficial not only for the management students but also for the students of statistics as well as economics and many others. So dear friends, we are going to take a very good topic, and the topic is goal programming. That is one of the lectures under operation research, and for this we have again with us in our studios Dr. Subhash Kakkar. As you all know that he frequently visits our EduSet lectures, and through these lectures he tries to give the best out of him to you. I hope that this lecture is also going to be one of his productive lectures. So over to you, Dr. Kakkar. Welcome once again to the CEC-UGC live lecture.
Thank you, Gitika, and good morning to viewers. And this lecture, today's lecture, is part of the series of lectures on operations research. I have covered a number of topics on operations research. Try to use operations research in the industry. And today's topic is also one of those topics which can be used in the industry for having solution to our different problems. Today's topic is goal programming. Earlier we have discussed linear programming, integer programming, etc. Formulation of the problem in goal programming is same as linear programming, a simple linear programming problem. And we have seen that in LP we have objective function and some constraints are given. Under those constraints, we have to find out the best possible solution in the form of objective function. But while working practically in life, there is not one single objective which is to be fulfilled, as in the case of LP. In real life problems, we are faced with a number of objectives which are to be fulfilled, and of course there are constraints, and we have to take care of all those constraints also. Number of objectives are more than one. For example, in a factory which is manufacturing different products, we have to give the production schedule so that we are able to maximize the profit. Profit from each unit is given to us, and the constraints regarding the availability of labor, availability of machines, and availability of machine hours is also given. And our single objective is to maximize the profit. Such a problem is called simple linear programming problem. But at the same time, we have other objectives also to be fulfilled. For example, the underutilization of labor should be minimum. Underutilization of machinery should also be minimum. One can have more constraint like overtime paid to the workers is also minimum. If one more objective can also be added, that we want a minimum profit of this much amount. I have given one main objective and 4 other objectives. I want all these objectives to be achieved while solving the problem. So far we had only one objective and we were able to give the solution to that problem. But other objectives are also to be taken care of while solving the problem. And such a problem is called goal programming problem. What all objectives I have told other than the profit maximization are called goal or goals to be achieved. And these goals, we may not be able to fulfill all the goals 100%. Some of the goals we will be able to achieve fully, and some of the goals we may not be able to achieve fully. And that depends upon the constraints given to us while finding a solution to the problem. We have to see how maximum we can achieve our goals so that we are able to achieve our target. And the second thing to be added here is all these goals do not have the same priority. Each goal is given a priority. Priority number 1, priority number 2, priority number 3, like this. And we have to take care of the goals depending upon the priority given to them. First priority is to be met by all means. And second priority, again we have to meet that also, but not at the cost of priority number 1. Similarly, the priority number 3, again this particular goal is also to be achieved, but not again at the cost of priority number 2, priority number 1. So we add priorities to the goals and solve the problem accordingly. Now these priorities are nothing but the goals, and each goal has a priority. How far we are able to achieve the goal is given by the deviation. The deviation is the amount by which the goal is either underachieved or overachieved. We have a different designation for underachievement and overachievement. Now, if I am to achieve a goal and I am adding something like deviation, then the aim is this deviation should be minimized so that I am able to achieve the goal. This is a nutshell concept behind goal programming, and this is something added on to the simple linear programming problem. We will see how to formulate this kind of problem and how to solve it. Let's again see that these priorities are to be achieved, these goals are to be achieved as per the priority. When I say priority, some weightage is given to these goals. Weight 1, weight 2, weight 3, like this. Weight 1 has got the topmost priority, weight 2 has got the second priority, and so on, and we have to take care of these priorities accordingly. Now, by now, I think I am able to make this thing clear. Goals are different from the objective function. In the problem, we have constraints. So far in the LP problem, we have studied the constraints, and these constraints are called functional constraints. Without taking care of these constraints, we are not able to operate the system. Fundamental rule is we should take care of these functional goals, functional constraints, before we go on to the priorities and the goals given in the problem. Next is the goals, etc., what are given to be achieved, and these goals are called goal constraints. So in a problem of goal programming, we have two types of goals. One is functional constraint and the other is goal constraint. Out of these two, the most priority is given to functional constraints, and by all means these constraints are to be met, and we can have compromise with the goal constraints as per the priority given to them. Now we'll see how we proceed to solve a goal programming problem. Goal programming may be used to solve linear programs with multiple objectives, with each objective viewed as a goal. The first statement in goal programming problem is we have more than one objective to be fulfilled, to be achieved. In a goal programming, DI plus and DI minus are the deviation variables or the amounts a targeted goal I is overachieved or underachieved respectively. Okay, this deviation DI plus and DI minus, as I have stated, overachieved or underachieved. When it is overachieved, it has a positive sign. When it is underachieved, it has a negative sign. We'll see how to formulate the problem, but at this stage we have to understand these deviations in the goals as DI plus and DI minus, and DII shows a particular priority goal. The third thing which we want to discuss is the goals themselves are subtracted and added to the constraint set with DI plus and DI minus acting as the surplus and slack variables. This statement will also be elaborated while having a solution to one of the problems. How these are added, how these are subtracted to make the equation possible. One approach to goal programming is to satisfy goals in priority sequence. Second priority goals are pursued without reducing the first priority goal. As I have already discussed, the most importance is to be given to the goal which is having the topmost priority, priority number 1. Then we have to achieve the second priority goal, not at the cost of the first priority goal. For each priority level, the objective function is to minimize the weighted sum of the goal deviations. I said these deviations are not accepted, but while solving a problem, they do come into the solution. If deviation is there from our objective or from our goal, this deviation should be minimum as far as possible. That is the aim of our problem, and we have to have a solution so that these deviations are minimum. Previous optimal achievement of goals are added to the constraint set so that they are not degraded while trying to achieve lesser priority goals. The statement means that the functional constraints are given the topmost priority, and those constraints are to be met by all means. And then we start achieving the goal specified in the problem as per the priority is given. Getting a solution to the problem, how to formulate it? First and foremost thing is formulation of the problem. Here we are discussing goal programming problem, so we have to formulate the goal programming problem. First step, decide the priority level of each goal. When the level has been decided, we will move on to the step number 2. Decide the weight on each goal. What is the priority being given? What is the weight being given to a particular goal? If a priority level has more than one goal, for each goal I decide the weight Wi to be placed on the deviation di plus and di minus from the goal. I will be given the priorities like 1, 2, 3. 1 means the first priority, 2 means the second priority. 1 means the topmost priority and the 2 means second most required priority. Step number 3, set up the initial linear program. Initial linear programming problem is to be formulated the way we used to formulate it. And then minimize. Objective function is W1 D1 plus W2 D2 minus like this, and these are the deviations from the desired goals are to be minimized. And goal constraints. Step 4, solve the current linear program. Now we will find the solution to the linear program. If there is a lower priority level, go to step 5, otherwise the final solution has been reached. In these 5 steps, we will be finding a solution to our goal programming problem. Step number 5 is set up the new linear program. Initial linear program has already been set. Consider the next lower priority level goal and formulate a new objective function based on these goals. Add a constraint requiring the achievement of the next higher priority level goals to be maintained. The new linear program might be minimize W3 D3 plus W4 D4 minus. D4I is nothing but the deviation, and functional constraints, goal constraints, and the objective function. W1 D1 plus W2 D2 minus is equal to K, and this K figure we have to minimize. Go to step 4, repeat step 4 and 5 until all priority levels have been examined and listed in the problem. Now we'll see one of the problems and we'll use this procedure to formulate and finally get a solution to it. The problem statement is, Inex Corporation manufactures 2 products, A and B. Product A requires 5 hours on machine 1 and 2 hours on machine 2. Product B requires 2 hours on machine 1 and 4 hours on machine 2. The weekly capacities of each machine 1 and 2 are 50 hours and 48 hours respectively. This is our problem. This is our simple linear programming problem. A manufacturing company is there and the company is in the manufacturing business. The products they are manufacturing are 2 in number. For manufacturing these 2 products, 2 machines are required, and the number of hours required on each machine by each product are also given, and total available hours of the 2 machines are also given as constraints. So this is our problem. First we have to understand the problem thoroughly, and we have to understand the key issues raised in the problem, and we have understood the problem, we have understood the key issues raised in the problem. Now, the company has 3 goals which are given below. Now we have to discuss the goal programming problem. Priority number 1, minimize underachievement of a total production of 10 units per week. This is goal number 1, priority number 1. Total production of 2 products should be a minimum of 10 in number. Product 1, product 2. If we add them, the total should not be less than 10. This is the priority number 1, goal number 1. Next is the priority number 2, minimize underachievement of producing 8 units of product A weekly. Now we have a goal for product A at the limit on the number of products to be produced is 8. And this is the goal number 2. Now we will discuss the priority number 3, and this is minimize underachievement of producing 13 units of product B weekly. Again, goal number 3 gives that a minimum 13 numbers of product B be produced. Now three goals are given, 3 priorities are given. I will repeat, the priority number 1 is on the total production of product A and product B, which is 10 in number. Second priority says that product A minimum production of 8 are required. Priority number 3, again it is on the product B, which is total number of product B to be produced, a minimum figure is 13. So these 3 priorities, and now we will see how to solve this problem so that these priorities are met to the maximum extent. First we will try to formulate the problem. Let us assume x1 is equal to the number of units of A produced weekly. X1 is the number of units of product A produced weekly, and similarly X2 is the number of units of product B produced weekly. And now DI minus and DI plus will add deviation variables. DI minus is the amount, the right hand side of the goal I is deficient. This is deficient production, and DI plus is the amount right hand side of the goal is exceeded. One is deficient, other is exceeded. Minus is deficient and plus is exceeded. We will see how to take care of these deviation variables. And the constraints, regular constraints of the simple linear programming problem are 5x1 plus 2x2 should be less than equal to 50. These are number of hours available on machine 1, and similarly 2x1 plus 4x2 is less than equal to 48. Again, number of hours available on the machine 2. 2 machines are required to manufacture these products. Now we will have the goal programming introduced in this particular problem. Our 3 goals are there, and how to take care of these 3 goals. First one, priority number 1, 10 total production weekly. Total production is nothing but x1 plus x2. Now x1 plus x2 plus d1 minus and minus d1 plus is equal to 10. Now we will concentrate on this particular equation so that we understand it once for all how this particular equation is made. The constraint is on the total production, and total production is x1 plus x2. And we want that minimum 10 number of product 1 and product 2 should be produced. If it is underachieved, underachievement is shown by D1 minus. If it is underachieved, if 10 is not met, if 8 are produced, then there is a deficiency of 2 numbers. It means this deficiency of 2 numbers should be added to x1 plus x2 to make it equal to 10. And this 2 is the deficient production, and deficiency we are showing it with D1 minus. So D1 minus, if it is a minus, if it is a deficient production, then it should be added. Similarly, in case overproduction is there, instead of 10 units, if we are making 12 units, means 2 units are extra produced, and x1 plus x2 is 12, and we want to make it equal to 10. Extra production is of 2 units, so we will subtract these 2 units from x1 plus x2, and this extra production or the production exceeds our requirement is 2, and this is denoted by D1 plus, and then this particular deviation will be subtracted, and so the equation is made x1 plus x2 plus D1 minus and minus D1 plus equal to 10. This is the first equation, first priority, and I have demonstrated how to make this equation. Now one thing to be understood, one thing to be noted here is it doesn't have any inequality sign. as in our linear programming problems. In the goals, we have equality signs because the equality is introduced only because of deviation variables. In this particular first equation, first priority D1 plus and D1 minus are added, and we have only equality sign. Now we will come to the second equation, and second equation gives us a goal of producing product A, and the number fixed is 8. Production of product A is given by x1. So we will have x1 plus d2 minus and minus d2 plus and equal to 8. So this is how the second priority is taken care of in forming the equation. Now the third priority, which is a goal for product B and its number to be produced, and the figure is 13. So x2 plus d3 minus and minus d3 plus is equal to 13, and these three equations take care of the three goals of different priorities. Now what we are going to minimize? We have to see whether it is D1 minus or D1 plus which is to be taken into account. We are worried about the underproduction. We are not worried about the overproduction. In all these three priorities or three goals, we are worried about underproduction. So underproduction is given by D minus. First equation D1 minus, second equation D2 minus, and third equation D3 minus. And our objective function must be that these three deviations should be minimum. So we will minimize D1 minus, D2 minus and D3 minus. Of course, we can add them. Before adding, we will multiply these deviations with their priorities. So our objective function is now minimize P1 D1 minus plus P2 D2 minus plus P3 D3 minus, and this is going to be our objective function because all these deviations are to be minimized. This is our goal, and this is the goal programming formulation. Now let us see how we have formulated it. As I have already explained, the objective function here is now minimize P1 D1 minus P2 D2 minus plus P3 D3 minus. Okay, and now our functional constraints of course will be taken into account. The first constraint and the second constraint, these constraints have already been formed. First is 5x1 plus 2x2 less than equal to 50. Next constraint is 2x1 plus 4x2 less than equal to 48. And our now three goals will also be added: x1 plus x2 plus d1 minus minus d1 plus equal to 10, and this is the same equation which we have already made. And now second priority x1 plus d2 minus minus d2 plus equal to 8, and the third priority is also introduced: x2 plus d3 minus minus d3 plus equal to 13. And now the last one, the non-negativity constraint. All these values x1, x2, d1 minus d1 plus, d2 minus d2 plus, d3 minus d3 plus should be greater than equal to 0. These cannot have negative values. This is our non-negativity constraint, and now this forms a formulation of the goal programming problem. I don't think the viewers have any problem in making the formulation for a goal programming problem. This has been clearly explained, and now I think most of the viewers will be able to form any goal programming problem given to them. Now we will have a solution to these problems. We will discuss the solution of this particular problem only, and this solution we'll explain thoroughly in a graphical method. First one is the graphical solution, and we have a simplex method also. Today we'll devote time on the graphical solution. And this graph, we have x-axis and y-axis. X-axis denote the x1 product. x1 is on the x-axis and the product A is on the x-axis. On the y-axis, product B is given, rather x2 is given. The first one, first we have to mark the constraints. There were two constraints. The first one is 5x1 plus 2x2 less than equal to 50. As in the graphical solution of the linear programming problem, the same method is used in goal programming. The first line is marked here, 5x1 plus 2x2 less than 50, and the second line is again for the constraint 2x1 plus 4x2 less than 48, because 50 hours and the 48 hours are the limiting factor on the availability of hours on the two machines, and these two constraints are marked. In our linear programming problem, the lower envelope where they intersect is the feasible region. And now we'll add to this graph the goal constraints. The first constraint has already been added. I'll remove it and show you its addition. This has been added. A line has been added which is for the first priority, which is for the first goal, where we want that total production should be 10. So x1 plus x2 should be 10, and this line is the line for x1 plus x2 equal to 10. I'll mark it there, and with the arrow I'll show it also. Look at the slide, and this is x1 plus x2. The first goal has already been marked. Now the lower envelope where our feasible solution was, now it has been reduced by this goal, and only a small portion is now left which is above this line of x1 plus x2. Rather, our solution should lie on this particular line to fulfill this constraint x1 plus x2. If there is any deviation from this, that will be our problem. So our solution lies on this first goal, first priority, and this priority is shown by the line x1 plus x2 equal to 10. Now we'll have the second goal. Second goal is nothing but x1 equal to 8. We want a minimum production of 8 units of product A. Now how this is going to be marked with the straight line? Just see on the slide. A vertical line has been added on the x-axis showing 8 units of production. Now our total feasible region is now reduced. Earlier we have a big bottom envelope which was reduced by x1 by x2 equal to 10. Now it is further reduced by the second priority goal. With a vertical line, it shows that our solution lies on only 2 points where the intersection of two lines is there. One line is 5x1 plus 2x2 less than 50, and the other line is x1 plus x2 equal to 10. Out of these 2 points, our solution will find a position. Now we have a third priority also. Third priority is the production of the second product, product B, should be a minimum of 13 numbers. Now how to show that? x2 is equal to 13, we'll show it with a horizontal line because x2 is on the y-axis. We'll show it with a horizontal line. So this line shows x2 is equal to 13. I'll mark it with a arrow also. So this arrow shows that this particular line. And this line, now look at the slide, this line is far away from the feasible region. It is not part of the feasible region, and this is what it shows, that this particular priority can never be met because this is a third priority. We cannot achieve the third priority at the cost of first priority and the second priority. Now we'll go back to our previous discussion where the solution lies. solution lies only on one of the 2 points, but the upper point maximizes something, okay, and the second point minimizes something. So we will have a point which is higher than the minimum point, which is our solution. Let's see what is our point. This particular point of intersection where x1 is equal to 8 and 5x1 plus 2x2 less than 50 are intersecting. This is our solution point. And what is this point? We can have by calculation. This point is 8, 5. 8, 5 means product A, 8 numbers be produced, and product B, 5 numbers be produced. Now, we will see how far we are able to achieve the goal. First goal was total a minimum of 10 units of production be there. Our production is 8 plus 5, 13. And second priority was a minimum of 8 units of product A be produced, and we are producing 8 units of product A. Both these priorities have already been fulfilled. Now we will go to the third priority. Third priority was a minimum of 13 units of product B be produced, and it is not possible to have 30 units of product B. So the third priority will be ignored at the cost of priority number 1 and priority number 2. I think I am able to explain clearly how this particular problem of goal programming is solved graphically. Of course, we will have one more example to be conversant with this goal programming graphical solution. Another problem, Conceptual Products is the name of the company, and it is a computer company that produces CP400 and CP500 computers. The computers use different motherboards produced in abundant supply by the company, but use the same cases and disk drives. The CP400 models use 2 floppy disk drives and no zip disk drive, whereas the CP500 models use 1 floppy disk drive and 1 zip disk drive. As I have already discussed, before solving the problem, before formulating the problem, we have to understand the key issues raised in the problem. The key issues raised are, first, it is a company manufacturing computers. Next is, the company is manufacturing 2 types of computers, namely CP400 and CP500. And both the computers use motherboards which are available in abundant supply because these are produced by the company itself. And then disk drives and floppy disk drives and zip disk drives are to be used in these computers. Their quantity, etc. is also mentioned in our next slide. The disk drives and cases are bought from vendors. There are 1000 floppy disk drives, 500 zip disk drives and 600 cases available to the Conceptual Products on a weekly basis. It takes 1 hour to manufacture a CP400 and its profit is 200, and it makes 1.5 hours to manufacture a CP500 and its profit is 500. Here again certain things are mentioned, key issues are also raised, like 1000 floppy disk drives, 500 zip disk drives and 600 cases, these 3 items, and their quantities are also given on weekly basis. And the number of hours required by these computers for manufacturing is also given, and the profit is also mentioned, how much profit one type of computer gives and how much profit the second type of computer gives. this slide also, we have clearly understood the key concepts which have been raised in this problem. Now, this problem gives us three priorities which are to be met, which are to be achieved, which are to be fulfilled. The company has three goals which are given below. The first goal, first priority, meet a state contract of 200 CP400 machines weekly. This is goal number one. There is a requirement of 200 units of CP400 computer, and this requirement has come from state. This is a priority number one, which is to be met by all means. Priority number two, make at least 500 total computers weekly. Now there is a goal for total production, CP400 and CP500. When added together, the quantity should be a minimum of 500. The priority number three, goal three, make at least 250,000 as profit weekly. And now this is again a requirement of the profit, which is 250,000. Now we'll see how far these priorities can be met. We'll have the same rule. That rule is we cannot achieve the priority number 3 at the cost of 1 and 2. We cannot achieve priority number 2 at the cost of 1. This single fundamental principle, this single fundamental requirement will always be kept in mind while finding the solution to the problem. Now we will formulate this problem. We will see how we are going to do it. Now variables to be considered are decision variables, of course deviation variables also. First one will have x1 and x2. x1 is the number of CP400 computers produced, x2 the number of CP500 computers produced. These two computers and their numbers are given by x1 and x2. And the deviations, as we have already discussed in the previous example, di minus di plus, both are deviation variables. Di minus is the amount the right hand side goal I is deficient, and di plus is the amount the right hand side of the goal I is exceeded. One is the deficiency and other is the excess. Deficiency is given by minus and excess is given by plus. And in the same way, we will give a proper treatment to these deviations depending upon the goal requirement. Now we will discuss the functional constraints which are stated in the problem. Based on the availability of spares of these computers, availability of floppy disk drives, 2x1 plus x2 less than 1000, because the quantity available is only 1000 weekly, and availability of zip disk drives x2 less than equal to 500, because only CP500 which is given by x2 uses zip disk drives, and the availability of cases x1 plus x2 less than equal to 600, because these cases are common to both the computers CP400 and CP500. That's why we have added them and we have kept inequality sign, and 600 is the figure on the right hand side. So x1 plus x2 is less than equal to 600, and our goals will be stated in the equations. The first goal, 200 CP 400 computers for the state weekly production. So how to make the equation? This is a limitation on CP400 computers, x1. So x1 plus d1 minus d1 plus is equal to 200. d1 minus is deficiency in production, d1 plus is excess of production. We have understood this clearly. And now second priority, second priority 500 total computers weekly. Total computers produced are nothing but x1 plus x2. So x1 plus x2 plus d2 minus d2 plus should be equal to 500. Now the third priority 250 in thousands the profit, because 200 is the profit on x1, 500 is the profit on x2. So viewers can now form the third equation on their own. Yes, the equation is now 0.2 x1 plus 0.5 x2 plus d3 minus d3 plus equal to 250. And these three goals, these three priorities and these three equations. Now we will add to these equations non-negativity constraint, that is x1, x2, di minus di plus, where I is 1, 2 and 3 greater than equal to 0, because these cannot have negative values. So priority number 1, objective function, minimize the amount the state contract is not met. So what is that figure? D1 minus is the deficiency in production of product A, CP400. So D1 minus is to be minimized. The priority number 2, minimize the number under 500 computers produced weekly, and this is given by D2 minus. So D2 minus is also to be minimized, and minimize the amount under 2,50,000 earned weekly, and this is given by D3 minus. All these deviations are deficiencies only, and the total of these deficiencies is to be minimized. This is our goal and we have to achieve it. Now we will formulate the problem as a goal programming problem. And formulation of the problem. So the first objective function is minimize P1 D1 minus plus P2 D2 minus plus P3 D3 minus, and all these are deviations, and these deviations from our requirement we want to minimize. And now our functional constraints will be added here. 2x1 plus x2 less than equal to 1000, x2 less than equal to 500, and x1 plus x2 less than equal to 600. And now goal constraints. The first goal constraint is x1 plus d1 minus d1 plus equal to 200, which is a state contract. The next goal is, next priority is x1 plus x2 plus d2 minus d2 plus, again equal to 500. The last priority, the last goal is 0.2 x1 plus 0.5 x2 plus d3 minus d3 plus equal to 250. Of course, we will add to this the non-negativity constraint. x1, x2, d1 minus d1 plus, d2 minus d2 plus, d3 minus d3 plus. All these values greater than equal to 0, and this complete our formulation of the problem. Now we will go to the graphical solution of this problem. To solve graphically, first graph the functional constraints. As usual, we have to mark the functional constraints, then graph the first goal, x1 200. Note on the next slide that there is a set of points that exceed x1 200 where d1 minus is 0. Our first priority, first goal met. We will go to the next slide. The next slide, we have marked the first constraint, functional constraint, and this is 2x1 plus x2 less than equal to 1000, the first constraint, and this has been shown by the straight line. The next is now, next functional constraint, 2x1 plus x2 less than 1000 is shown by this straight line. And now this is the x2 should be less than equal to 500, and this is given by a horizontal line. This is also a functional constraint. And now x1 plus x2 should be less than equal to 600. This will also be shown by a straight line. This is the second functional constraint. So these three lines and these functional constraints. And now look at the lower envelope, which is the feasible solution, and part of it is marked red also. And this feasible region and where our solution lies, now we have to add on to this our three goals. First goal, second goal, and third goal. First goal is production of CP400 computers. A minimum production of 200 is accepted. So we'll mark it here. This constraint has been shown, x1 plus x2 less than equal to 600. And now the first goal has been added with a vertical line because it is the production on the quantity of production of CP400, 200 and specified. And our feasible solution is reduced, and this solution is feasible region is only the area which is marked red. Goal 1 has been added, x1 greater than 200. So this is a feasible region which is marked by red. Here we have added so far 3 functional constraints and 1 goal constraint, and we now have a feasible region. And now we will go to the second priority, second goal, we will mark it here. First we will see how this x1 is greater than 200 is marked with a vertical line. Point satisfying goal 1, this is the feasible region which is marked red. Clearly visible the feasible region, our solution will lie somewhere in this feasible region also. So far functional constraints and the goal 1 has been marked here on this graph. Of course we will go to the goal 2 and then finally goal 3 also. Now add goal 1 as x1 greater than 200 and graph goal 2 x1 plus x2 500. This is our second goal. Note on the next slide that there is still a set of points satisfying the first goal that also satisfies the second goal. D2 minus is 0. Let's see on the graph. This is our earlier drawing or the graph. We'll add on it the second priority also. Let's see how to mark it. And this line is the second priority. And now this small region, points satisfying both goals 1 and 2. Now the feasible region has been reduced and it is reduced to a small slice only. Earlier the red area was bigger and now particularly this area is now reduced. Goal 2 is x1 plus x2 greater than 500. That was our second goal. And this area covers the second goal also. This line gives the second goal, x1 plus x2 greater than equal to 500. Now it is clearly marked also. The red area is marked with a small slice. Earlier, the previous slide, the feasible region was bigger. Now the moment we add the second goal, this feasible region is reduced. And now our solution will lie in this area only. Now we will see the maximum profit also, the third goal. Maximum profit of 2,50,000. How to mark it, we will see. Now the third goal, now add goal 2 as x1 plus x2 greater than equal to 500 and goal 3, 0.2 x1 plus 0.5 x2 equal to 250. Note on the next slide that no point satisfies the previous functional constraints and goals and satisfy this constraint. It means that goal 3 is not possible to be achieved. Thus, to minimize D3 minus, this minimum value is achieved when we maximize 0.2 x1 plus 0.5 x2. Note that this occurs at x1 equal to 200 and x2 equal to 100, so that 0.2 x1 plus 0.5 x2 is only 2,40,000. So D3 minus is 10,000. So D3 minus means deviation will be there in the third priority. We'll see on the graph. This was our previous graph where a small region which is feasible was given. Now we'll add to it our third goal also. This has been added, and this shows that this can never be achieved. So company can make only 2,40,000 profit instead of 2,50,000. So our two priorities have been met, two goals have been met. As I explained in the beginning, we are given a number of goals, and some of the goals we are able to achieve, and some of the goals we are not able to achieve, and some of the goals we are not able to achieve fully. But we have to achieve these goals as per the priorities. In this particular example, we have seen that only the first priority and the second priority are fully met, but the third priority is not met. And this is the game of the goal probing problem. We achieve some of the goals, we are not able to achieve some of the goals. But here in these kind of problems, our objectives are more than one which are to be achieved. I think viewers are able to understand the goal probing problem, its solution, and they will understand it further if they practice themselves with more problems and get conversant with the solution.
Definitely, sir. I hope that our today's goal is fulfilled because you have delivered such a productive session. I hope that all the students might have liked it, and you can watch this lecture again through YouTube. Dr. Kakkad would be again in future lectures, and we would be learning more programming through him. Thank you, sir. Thank you so very much.
Thank you.